In this video, we're going to identify all the critical points and identify each individual critical point. So you've got your surface. Critical points occur when this equals 0 and this equals 0. So we need to work out the partial derivative with respect to x. So looking at your surface, differentiate this, partially differentiate it with respect to x. That will then give us this. And then partially differentiate it with respect to y. That will then give us this. So we want to find values of x and y such that this whole thing here equals 0 and this whole thing here equals 0. So factorize it. Factorize this. That will then give us this thing here. Factorize this. That will then give us this thing here. So we want to find x and y such that this thing here equals 0. This thing here equals 0. Well, we want this to be 0. So either this block is 0 or this block is 0. And then looking at this, we want either this to be 0 or this to be 0. So let's look at a case where y equals 0. So looking at this, so you've got 4 blocks here. 1, 2, 3, 4. Let's look at a case where y equals 0. When y equals 0, this whole thing here will automatically be 0. So when y equals 0, looking at this, if you select x to be 0, then both of these will be 0. So we know that there's one critical point at the origin. Because when y is 0, if you put 0 into here, then both of these will be 0. So we've got one point already at the origin. So at the origin, this thing here equals 0 and this thing here equals 0. And then when y equals 0, looking at this block, when y equals 0, you put 0 into here. This thing here would disappear. So it boils down to 5x minus 15. 5x minus 15. So you want this thing here to be 0. So when y equals 0, x, looking at this, add 15 divided by 5, x equals 3. So when y equals 0, so along here, when y equals 0, at the origin, both of these would be 0. So that's a critical point. And then this one here says that when y equals 0, x would be 3. So 3 will be somewhere around here. So we've got another critical point here. We've got a critical point here and another one here. So now looking at these 4 blocks, when x equals 0, this whole thing here would be 0. So that means going back to here, if we demand this to be 0, then we've got another critical point. So when x equals 0, if you put 0 into here, this will be 0. So you can see if you demand this to be 0, then this will be 0 and this will be 0. So when x is 0, so you put 0 into here, demand this whole thing to be 0, meaning y minus 15 must be 0. So you've got another critical point here. When x equals 0, y will be 15. Y will be 15. So you've got another critical point somewhere up here, not to scale. 15 would be somewhere up here. Well, you've got another critical point. X equals 0, y equals 15 is another critical point. So now the last scenario is when this thing here equals 0, this thing here equals 0. So you want both of these to be 0 somehow. So looking at these two, if we hang on, let's go back to here. So looking at these two, if we rearrange this to make y the subject, so add 15 divided by add 15 and then take away 10x. Looking at this thing here, we want to make both of these to be 0. So let's demand this to be 0. So 10x plus y equals 0. Add 15 to both sides, and then take away 10x. So y equals this. So if you plot this graph, y equals 15 minus 10x, it will look something like this. You've got your intercept of 15 going downhill with a gradient of negative 10. So along here, along this line here, everything here will be 0. If everything here is 0, then the whole thing here is 0. So along here, this thing here will be 0. So hang on. Along here, 15. This whole thing here will be 0. And then looking at this, set this to 0. 15x plus 2y minus 15 equals 0. Add 15 to both sides. Take away 5x divided by 2. So if you sketch this, it will look something like this. 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 So along here, everything would be 0. Hang on. Along here, everything here would be 0. Everything here will be 0. Along the other line, everything here would be 0. So meaning, hang on. Along here, everything would be 0 on this one here, and then along here, everything over here would be 0. So there's a point here where both of them would be 0. So there exists a point here where both of them would be 0. So our job is to find this point here. So that point there, if you work it out, it happens to be at x equals 1 and y equals 5. So at this point here, at that point there, x equals 1, y equals 5, this thing here would be 0, this thing here would be 0, making both of these 0. So you've got a critical point at, I hope you understand that, at x equals 1 and y equals 5, both of those would be 0. So we've got all our critical points here. We've got one here, one here, one here, and another one here. Hang on, have I done this right? Let me think. Let me think. Let me think. Have I done this one right? Let me think. When x equals 0, what is y? When x equals 0, what is y? Hang on. When x equals 0, sorry, when x equals 1. When x equals 1, yeah, okay, I think I've done it right. So so we've got a critical point here. Hang on. Yeah, I think I've done it right. Yeah. What was confusing me was this 15 here. So you y equals 15 here. So I've located that. Well, anyway, I've confused you, but overall we've got 4 critical points: one here, one here, one here, and one here. So now we just need to perform the second derivative test. So this is the formal second derivative test. I've summarized it to this. So when you come to perform the second derivative test, just compute this value here. Compute this value here. So when you look at this in your mind, picture this box. Picture this. If it's less than 0, then you're going to get a saddle. If it's here, it could be a local max or it could be a local min. So next step is to look at this. If it concaves down, local max. If it concaves up, then it's local min. So anyway, we need to perform this value here. So to perform the second derivative test, we need to figure out xx, yy, and xy. So we need to compute this thing here. So let's look at our surface again. Let's look at our surface again. This is our surface. We've done this. Fx equals this. Fy equals this. We've done this. Now we need xx. Well, xx equals this. Xx equals this thing here. Fyy equals this thing. Fxy equals this thing here. So I'm assuming you can do this by now. So that will give us this thing here, and this thing here. We need these things in order to compute this value here. So at the critical point, at the origin 0, 0, we need fxx. So we need to put this into here. And yy is this thing here. We've got to put, oops, hang on. This is the y, it should go into here. This is the x, it should go into here. So so looking at this times this will be 0 times 0, and then you've got your minus, and then now we need xy, fxy is this thing here. So we need to put 0 into here. We need to put this into here, which would be 0, and then minus 15. So you've got your minus 15 squared. Well, this whole thing here would be less than 0. If it's less than 0, then it's going to be a saddle point. So so at the origin, it's going to be a saddle point. And then look at this critical point here, 0, 15. 0, 15. So xx will be this. So you've got to put the y value here into the xx. And then looking at this yy, this is yy here. We've got to put the 0 into the x here. That would be 150 times 0, and then you've got your minus, and then you've got xy. Well, xy is this thing here. So now we've got to put 0 into the x, 15 into the y, take away 15. That boils down to this. It turns out to be less than 0, which will be a saddle point. So now let's look at the critical point 3, 0. 3, 0, put 3, well, looking at xx would be this thing here. And it's blah, blah, blah. It will then give you this thing here. It will then give you, it will be less than 0. So it's going to be a saddle point. When it comes to this one here, 1, 5. Well, 1, 5, if you compute this thing here will be greater than 0. Well, if it's greater than 0, hang on. If it's greater than 0, hang on. If it's greater than 0, it could be this thing here, or it could be this thing here. So now we need to look at xx. If it concaves, if it's negative, then it's going to concave down, meaning it's a max. If it's a positive, if this thing here is a positive, it's going to concave up, meaning you're at local min. So when you come to compute this, for the last one, hang on. For the last one, it turns out to be greater than 0. So it could be a max or it could be a min. So now we look at xx. Well, xx turns out to be greater than 0 because look at xx. Hang on. Bear with me. Look at xx here. This is xx here. Xx here will be 10y. Well, 10y, this is y here. 10 times y will be 50. Well, this 50 is bigger than 0. So so it's going to concave up. If it concaves up, then you know you're at a local min. So overall, this is your final answer. Okay.